So hello everyone. So we are AGL committee members. So my name is Naoto Yamaguchi, and second speaker is Harunobu Kurokawa, and on-site member is uh, Yuichi Sakabe and Yashimo Mora. So let's start talk. Please, let's start Kurokawa-san.
Okay. So first, what is the software defined? Yeah. Do you know what is this? So this is air conditioner. When I worked visited the Taiwan this year, this summer, it's very, very hot in this summer. So it's a very, very old and traditional one. So for example, it's using the hardware button to control only turn on and turn off. It cannot control the temperature in this mechanical. はい。On the other hand, another AGL member stay another hotel. It's normal. So this air conductor using the remote control, it's digital. For example, hardware, it controls the temperature and turn off, etc. I think it is a normal one. はい。And recently, most of the case, you can control your own device. This software is installed after you buy the air conductor and so on, or your smartphone is not installed it, but this is can control to from your side. I think it's software-oriented system. The same software evolution is occurring in automotive situation. For example, meter, it's a mechanical meter. Recently, digital meter. And for the future, many software installed after launch the vehicle. So this is software vehicles, we think. So sorry for the late introduction. I'm Harunobu Kurokawa, working Renesas Electronics Corporation, and I'm working since 2007. And right now, I'm working in the Linux OSS and Team OSS Manager. And in community cases, I joined AGL development from 2016. From this year, I joined Zen community and Zen project and each working group and boards. And in addition, I'm a knight of Kusakabe-san team. Please, next speaker.
Hi, my name is Naoto Yamaguchi from AISIN Corporations. I work on the over 15 years in this company. So I working embedded software engineer since 2027, and I work for the Linux and OSS automotive development under 2011. So I joined to the AGL in 2014, and I joined to ELISA 2019. So I first information is what is automotive grade Linux. I want to share our committee information. So overview of the Azure. So it's an open source project for automotive world. So Azure targeting to the initially Azure launched to the create a common IVA open source platform about 10 years ago. So recently, Azure covered the cockpit system and the telematics system, not only infotainment system. So most recently target is SDV, software defined vehicle, and open source program office topics. And AGL two key procedures, two key procedure. One of the incubate and develop. Incubate and develop open source software components to cover the automotive specific use case. Second key procedure is integrate. AGL aim to integrate a Linux-based automotive software platform to share good practice. So our member is as shown. So platinum member is 5, one gold member and 5 silver member and more bronze members. So AGL developed for the unified code base. Unified code base including base OSS and best OSS for automotive. And OSS developed by the AGL and innovative automotive OSS for automotive. So it's constructed from various open source software. So best open source software for Linux and the best open source software for automotive use and other open source software. And UCB is a repository, not a fork. AGL refers to existing open source repository. And self-hosting to AGL developed OSS. These softwares. And UCB is an incubator. First one, AGL UCB incubate AGL demo software to evaluate AGL softwares. So AGL demo software integrates using UCB, and it aims to show one of the best practice of AGL-based full software stack. So another one is incubate AGL-based product. So your company pick up from the some software from AGL UCB. It does not have a restriction, such as a compliance program and the certification and etc. And your company possible to add in-house softwares. As a result, your company can build up your product your product. So today I informed to the incubated product from UCB. Toyota and Suzuki announced the official launch of the product powered by automotive grade Linux. So it's a Toyota web page, and it shows it describes Toyota's product developed by the automotive grade Linux. And another one is Qt companies. Qt company announced the Suzuki using the automotive grade Linux and build on product. So conclusion for what is AGL? AGL is a technology incubator for the automotive industry. All technology is constructed with open source software. And AGL focused to the system integration using open source software whose scope is not limited to Linux distributions. And the collaboration method of AGL. First one, AGL shares a generic part of the system by code. Next one, AGL shares a specific part of the system by document, such as a presentation of the all-member meeting and this workshop. So AGL users, it's not limited to the member companies. Develop a product using the using AGL technology seed. So some product is incubated by AGL in this year. That's all for the AGL information. So next one is what is SoDeV? So let's please start, Kurokawa-san.
Okay. So it's a background for evaluation of big software. For example, today there is many ECU in the vehicle, in-stem cluster, IVI, etc. Many hardware inside. And software viewpoint, it strongly depends on hardware, so that different software is inside. So currently, very complex to the system in the vehicle. And so it's the vehicle physical system migrate from this ultra complex and distributed system to we need to migrate to the simplest integrated system. Right side, for example, AGL future predictions. So, for example, the multiple future will integrated one system. In this case, the hardware and decoupling system is needed, we thought. And one system, but multiple software is important. So that hardware decoupling is most important things. Reduce complexity, use the same software, and easy to upgrade and more for software. So AGL focus on achieving this hardware decoupling. So our AGL want to use the VAD IO. So this our proposal is VAD IO is common and generic hardware interface in automotive systems. The key points. First, VAD IO is a standardized interface for efficient I/O controls in virtualized environment. So, for example, so it makes fast communication between guest VM virtualized machine and host side. And guest side, the guest system domain sends some request to host side through VAD IO system instead of using real hardware devices. So it realized the decoupling hardware system between using this system. And VAD IO, it's an open standard. And already some open software supported it, as well known as kernel, Zen, KVM, etc. So it achieves software reusability between automotive systems. So AGL will use VAD IO to hardware decoupling features. In AGL SDV, so it will be must be used the open source software. So of course, we adopt open source technologies and apply automotive requirement to each OSS. And we focus on implementation rather than specification, define the specification because it's code first policy. Finally, we will integrate the implemented stacks, and after that, it makes it everyone can use it. So Yamaguchi-san states the appropriate software is implemented in common software stack during your product development phases. So now there is 5 major features will be integrated in this architecture: unified HMI, VAD IO, Zen, and Yokt and Zephyr. It's well known in the community and almost hosts a Linux Foundation, etc. So AGL will use as is from each project. To achieve this architecture, the reference SDV platform will be provided by AGL. This is SoDeV. From this, I will explain the detail and high-level architecture. Here is SoDeV architecture. This diagram will be is based on then components, control domain, driver domain, and guest domain for each one, like this. So from the next slide, I will explain why this component is needed. So please. First one, we selected open source type 1 hypervisor for virtualization, for performance and some things, etc. Then hypervisor is selected as a reference implementation in this SoDeV architecture. Next one is guest domains, guest VM edges. It will be support for selecting multiple guest OS for Android and AGL for each, and as well as their companies combined the use case as like as an instrument cluster to side by side. And here is part IO cases. Left side, the backend driver will be available for each. The backend driver handles the hardware access in behalf of the guest domain. It's handled to hardware. On the other hand, guest side, guest domain or domain will be used the BAT-IO front end. This BAT-IO for guest domain, it achieves hardware decoupling. This enhances the usability of multiple guest VMs. Unified HMI. This is a display framework and remote GPU control this one. It enables the integrated display virtualization and flexible UX development. Next page, I will explain more detailed one. This is Unified HMI. Unified HMI is developed in the AGL SDV EG. Unified HMI is multiple display virtualization platform based on GPU, BAT-IO GPU. It can support some features. Unified HMI allows the flexible development for the entire cockpit and cabin UI UXs. This can across the multiple display, but each display is independent hardware and OS configuration. For example, the right side picture, legacy case, one ECU handle one display, for example, but Unified HMI can support multiple ECU can handle multiple display. It's a high-level architecture. So there is two features. First one is a remote BAT-IO GPU device. Remote, this one is render application remotely from different SoC. For example, different VM or SoC handle another display. This remotely rendering for remote GPU. Second feature is distributed display framework. For example, multiple display is handled single these frameworks. So a user can develop flexible layout control it's across different displays. So this is a main feature in the unified HMI. So next, so we will use Zephyr RTOS and RT Linux in this architecture. As well, and also Zephyr RTOS is deterministic real-time scheduling, and average reusability through the lightweight OS to support. Utilize of RT Linux also similar. So we will integrate the for the future in this SoDeV architecture. And finally, this Zen and Zephyr, DOM0 Zephyr is one of the use cases. A configuration is to maximize the use of the Zephyr and Zephyr aiming for safety in this project. So we will reuse this achievement for the product so that it's one of the major architectures. Here is reference use cases. SoDeV and big physical system architectures. So SoDeV scalability is here. For example, zone and central vehicle system in architecture, it's required high performance computing systems. In this case, SoDeV will be enables many functional domain on BAT.io and runtime environment in this control this system architecture. And another cases, here is a different domain architecture cases. For domain vehicle physical system architecture, it will be different feature is required. However, SoDeV will be enable scaling to fit each domain control features using BAT.io runtime environment so that it's a scalable. You can use each domain for scalables. The conclusion of this SoDeV. SoDeV is a reference SDV platform. It will be accelerated by open source technologies. So SoDeV focus on hardware decoupling. It will to realize software reusability. It's accelerated by BAT.io infrastructures and focus on VM-based architecture to realize system scalability. It's accelerated by hypervisor infrastructure and focus on integrate deterministic and non-deterministic software into one system using virtual machines. For example, remote rendering capability for deterministic domain accelerated by AGL's unified HMI. On the other hand, accelerate some SDV trends such as cloud development cases and real cases, but it's a scalable. So there is a research point in the AGL and the SDV EG.
So next point is the SoDeV and the safety collaboration point. That means AGL collaboration point and the AGL committee and the ELISA committee. So today I informed to the SoDeV architecture. So I want to talk about antinomy between SoDeV and the safety. So the first point, what is the difference between SoDeV and ELISA system working architectures? SoDeV is this one, and the system working architecture is so basically same. So my understanding is that SoDeV is one more breakdown from the ELISA architecture. So SoDeV defined the hardware decoupling, not only a software domain isolation. It's an extension point from the ELISA system working architecture, working architecture, and device specific domain, DOMD, from user VM. And DOMU software shall be reused with other systems. So easy to port from this system and other systems. So our learning point for the Linux in safety critical system, it's pick up from the Philips slide. So assessing whether a system is safe requires understanding the system sufficiently. Understanding the Linux within the system context and how to Linux is used in the system. And the select Linux component and the feature that can be evaluated for safety. And identify gaps that exist whether more work is needed to evaluate safety sufficient. So it's very easy and as our understanding. So what is achievement? So that answer is how to achieve safety. So this slide shows the example use case for Telltale for instrument cluster. So we investigate how to integrate Telltale function in this SoDeV architecture and the SoDeV-based systems. So first one, instrument cluster part draw by the Telltale in hardware decoupled domain. Example is this one. So on just the hard, so Telltale monitoring mechanism shall work just before the output. So that means first one, so display hardware pick up from the image from the frame buffer, and this display output hardware generate output signal. After this pipeline, Telltale checker shall be check this Telltale availability. So safety function could not decouple the hardware. It's my question point. And that is answering between the hardware decoupling and the safety. So another design for this engine. So Telltale drawing the same part. And monitoring feature stay on the another safety part. And it use monitoring interface of the hardware part. So this point is this we call it DOMU, so guest domain. Our mind is shall be decouple the hardware, not control hardware directly. So one of the designs is set monitoring configuration from safe guest domain to driver domain. And the driver domain controls the Telltale checker. So it's one of the idea, but need to investigate and discuss this engineering. So we want to discuss what is the best solution and create common telltale monitoring interface between DOMD and DOME. How to create it? So shall we create the part IO telltale? So maybe it's not good. So it's very specific interface. Shall we create other interface? So it's a entry point from the hardware decoupling and the safety. It's very big issue for SODEV development. And the next one is a deterministic runtime environment. So currently, Azure doesn't have a deterministic runtime environment. That point work by the subcommittees such as the ESCOR project and the HAROS project. So Azure will follow and integrate with SODEV. So we need to investigate whether these activities are possible to reuse on bad IO runtime environment. So because our mind is shall we decouple the hardware in the reusable software? It's possible or not. So uh, we need to investigate and discuss. But only Azure, it's so difficult. So we want to discuss in this topic. Second. So last topic is our development activity for SODEV and other Azure. Please start, Kurokawa-san.
Yep. Okay, it's roughly the schedule UCB, AGL UCB, and SODEV. UCB is already available and scheduled this line. And in this year, the blue part, AGL soft development is started using the Renesas Arca H3 basis. In this year, we are initial trial development using this one. So in AGL AMM Tokyo and Berlin, we are using the differently. In Tokyo, we are starting this result, and AGL member integrates this trial. And in this summer to event, AGL AMM, we demonstrate using a Kingfisher board using 2 displays and COSCAP of the Taiwan event, and same demonstration is occurred. Now we are switching to the new development hardware. It's a new one from the Renesas V4H Sparrowhawk. Today, we now development is available for UCB to support. It's just a start in this quarter. And for the future, we will start using it as SODEV development from next year. In parallel, we are contribute and migrate in the UCB itself, and we will trying to demonstrate using this hardware on next year's event, Embedded World, AMM, and others. It's roughly our schedule. Last one is what different point existing reference hardware and new reference hardware. Left side is legacy H3. And right one is new one, before is Sparrowhawk. The blue part is a future point, the upgradable points. It's inside architecture, it's different. GPU, CPU, NPU, GPU, etc. Main point is it's a small size of rather than this Raspberry Pi displays. That's all this presentation. Thank you for the listening and voting. Thank you.
Thank you.
Do you have any questions?
Oh, yeah, first one. Yeah, so thank you very much for the presentation. So you care a lot about safety, but I haven't seen anything regarding compliance. So is there ISO 262 or ASIL-D or ASIL-A or what does automotive grade means translated to ISO 262?
SoDeV architecture focus to the much HDD Max because it focused to the RT deterministic domain. So at first we will try to the HLB in its focus to the instrument cluster. So it's step by step.
And right now, so in my understanding, personal opinion, so AGL does not focus HCL compliance itself. We would like to adapt each project result for Zen and Zephyr and etc. It's one of the scope and HCL safety compliance.
Okay. So ASIL-B is the next step.
So it has been done in the product mentioned, right? So that there is the EBITARA that was mentioned. That is in the instrument cluster, right? With containers. So basically the step here is instead of containers, we apply the hypervisor and extend it to become more like the ELISA reference architecture. So basically the what we have is essentially ASIL product, ASIL-B on the road for instrument cluster. And now basically we are replacing the containers with the hypervisor and extending it. So that's the next steps.
So my understanding that AGL SDV is no plan to ACL certification because I'm from Honda Motor, and in real product, ACL certification very depend on hardware and system design. So in this means a very different hardware as a OEM vendor and tier one company. So in this means very too difficult. One platform support all hardware and all requirements.
Yeah.
So this is a very difficult. So and AGL SDV is a different platform. And so in this means Honda and other OEM and tier one company using the SoDeV. So in this means very easy to starting point, a very high point, and easy to set up, and some open source software are very easy using to in real product. So this is my our AGL member motivation.
Okay. So we think so focused, not get the certification. That means we should choose ASIL related open source software such as Zephyr and then it will support the final products. And we invested in the RT Linux based solution and as a good solution. It will support the final product certification.
Yeah, okay. Well, for safety compliance, you should have something like a safety plan and then talk about it and say we have ASIL-B and we have statement coverage and we have this kind of risk analysis and so things that may be reusable. Of course, the certification will be done at the end on a certain hardware, but everything you have, let's say, out of context reusable is valuable and simplifies and eases the certification for certain hardware. So that's, and this is something when you do say automotive grade, or this is like for a safety expert, it's called him in nothing because nothing remains. I have no idea what this means. But if you say ASIL B, we have a safety plan, and these are the steps, and okay, then I know what you have done and what needs to be done. So this is a different, let's say, way of marketing it, I would call it. So I have no doubt that it is safe, but just
all
providing things.
All AGL stuff is used for safety related applications. It's
Yeah,
having,
that's why my
Yeah.
question is, what is safety? What does it mean? AGL, so is it just QM or is there something ASIL grade thing?
For the IVI, it's clear.
Yeah, okay.
For the instrument cluster build, they brought it to ASIL B,
Yeah, that's good. Thank you.
but for their specific product. So I think the landscape is evolving. We had to talk previously about the Sphinx solution, or basically the tooling, open source tooling for the essentially the demo, right? So that is, for example, something we can look into with the members if we put parts of that workflow in AGL. That's actually an interesting piece here.
Would be a big step forward.
But again, that needs to come from members. Patch is welcome.
Yeah.
And the question is, what is the common bits, right? So what is the common bits? What's hardware specific? What's product specific? I think, yeah, we need to distill down what is the common ground.
Yeah, very good.
And that was this point about the separation between the information that is created by AJ portion of software, and after that it should be checked against what is the output of the hardware. And then this check happens like that this level that we are decoupling the information that was created according to algorithm from the hardware specific information, how this hardware will check that this information is correct, or because it was transformed, and it should come back in exactly the same way, or twice, or in a similar way, or twice it cannot be checked. Like how we are looking back this information, what was not completely clear for me.
Yeah, I mean, it's also something which is not fully settled yet, right? Because basically, when you would like to render things for the instrument cluster with telltales, this is a rendering in the forward pass, but you need to check, and this is what Yamaguchi-san said. So you will need to read back as close to the display as you can get. These are like region of interest checker, display content checker, or whatever you take, and these are hardware specific. So I assume the discussion would also be like, can we come up with some kind of interfacing that the overall monitoring observation parts remain stable, and that you abstract this either with a Word IO interface, maybe not, it may be too specific on something on this use case, or you need to come up with other ideas. At the end, I mean, Word IO is doing a kind of decoupling, but there need to be somewhere a Word IO support, which basically tells you my physical hardware speaks with interfaces which are described in the way how Word IO is described, right? And this kind of safety parts are like for Telltale, so these are not yet there. And I guess this is what Yamaguchi wants to bring up.
Even maybe not even from the physical point of view, but it is not clear how it is foreseen to decouple them on this level. So, like, which portion of this architecture on the software can collect this information and compare this information?
Yeah, I guess that's what's also a discussion point what AGL maybe then together with ELISA would like to come up and figure out, like, does it actually make sense or so. We need to conclude because we're at the end of the talk time, and I guess Simone, you're next, right?
Yes.
Yeah, will you come to the front? Because otherwise you need to scream all the time.